Climbing up a tree, climbing up a tree. I'm just sitting here climbing up a tree. Nope, I'm not actually climbing up a tree. But if you look at the picture in the background, there's a tree and there's a right triangle, and we're going to be doing stuff with right triangles today. So my made-up song wasn't totally out of this world. But anyway, we are starting chapter 10, and this whole chapter deals with um, trigonometry, things with right triangles, and things with radicals. So we're going to start off with the classic theorem dealing with trigonometry. It's called the Pythagorean Theorem. All right, so our two learning targets here, one is to solve problems using the Pythagorean Theorem, and two, to identify right triangles. Okay, so let's start off with a little bit of vocabulary. Um, First, got to know the parts of a right triangle. Gonna quick review those. First part is the hypotenuse. The hypotenuse is the side opposite the right angle in a right triangle. It is also the longest side on the triangle. Kind of reminds you of a hippopotamus. Hippopotamuses have huge mouths. I don't know, so that has to do with the longest side. But the longest side of a right triangle is called the hypotenuse. Now, the leg or legs are the other two sides, each of the sides that form the right angle of the right triangle. So in other words, the smaller two sides would be the legs here. All right, the Pythagorean theorem is in any right triangle, this is what it says. We'll review this in a second. But in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. In other words, a squared plus b squared equals c squared, when a and b are the legs and c is the hypotenuse. So that's what we're going to be working with a lot today. Now, we are going to talk about figuring out if things are right triangles or not, so we're going to have to kind of know these terminology. I have them separated because they're not necessarily essential to write down, but just so you know the terminology. A conditional statement is an if-then statement. So like if it rains outside, then the grass will be wet. That's an if-then statement. Okay? Just so you know, that's kind of what we're going to be using a little bit of today with the Pythagorean theorem. The hypotenuse, I'm screwing that up. The hypothesis of a conditional is the part that follows if. So it's the if part. So in other words, if it rains outside, then the grass will be wet. The it's raining outside is the hypothesis. The conclusion then would be the then part. So then it will rain outside, or the grass will be wet. Sorry. And finally, the converse is a statement containing or obtained by reversing the hypothesis and the conclusion of a conditional. So you're flipping it around. So we're using the converse of the Pythagorean theorem today. But let's get into that Pythagorean theorem. All right, in words, or in this, here's the Pythagorean theorem in algebra. In words right here, it's in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So this is labeled A, B, C for this right triangle. And again, the important part is this only works in right triangles. Okay, so really A and B can be switched around. I usually say go smallest to largest, but the hypotenuse always has to be C. So here's an example. So if we're going to find the length of the hypotenuse, that's the easiest way to use this. So it says the tiles at the right are squares with 6-inch sides. What is the length of the hypotenuse of the right triangle shown? So the square we cut in half, and it's a little bit kind of weird angle, but this is a right angle here. So we have a leg of 6 and another leg of 6, and we're trying to find the hypotenuse. So we're going to use the Pythagorean theorem. What we have is two legs, so we can plug in for a and b. So we have 6 squared plus 6 squared equals c squared. We substituted in for a and b. Now we're going to simplify. 6 squared is 36, and 6 squared is 36, so we add those two together, we get 72 is equal to c squared. But that doesn't tell us what c is equal to yet, so we're going to take the square root. So it's the same thing as doing something to both sides. When we take the square root of c squared, that kind of cancels out the exponent. So we're left with c, and then we have to find the square root of 72. And we're going to estimate it to be 8.5. And that would be inches using a calculator. what we're going to do in the next section actually is going to find different ways to reduce radicals like that, the square root of 72. But for right now, we're just going to use a calculator and round it. Okay? Now, I would like you to pause it and to try doing that same thing. Here's the example. It says, what is the length of the hypotenuse of a right triangle with the legs of length 9 centimeters and 12 centimeters? So why don't you start by drawing that out? I'm going to draw the right triangle. We have 9 centimeters. We have 12 centimeters. And we're trying to find the hypotenuse. So go ahead and pause it and find it, and then you can unpause it and check. Alrighty. So after drawing my little shape, and I got the length of 9 and 12 for the legs, it is a right triangle, so we know we can use the Pythagorean Theorem, which is a squared plus b squared equals c squared. And we're plugging in for a and b here. We're trying to find the hypotenuse, which is always c. So I plugged in here, simplify the square, so I got 81 plus 144 equals c squared, and that 81 plus 144 is 225. So 225 equals c squared. To figure out c, we have to take the square root. So then the square root of c squared is just c, and the square root of 225 is 25. So our answer is 25 centimeters. All right, now sometimes you may be asked to find the length of a leg of a right triangle. So if we look at our triangle to the right, and ignore the bottom one, we're just going to do the top one right now. It says, what is the side length B in the right triangle? So now we have a leg and the hypotenuse, and we're trying to find another leg, which is B. So we know it's a right triangle, so we can use the Pythagorean theorem as long as we're dealing with all side lengths. Now we're going to plug in for, this is going to be our A. It doesn't really matter. This could be our A or our B, but we're going to use the missing one as B. And then plug in 13 for C. So we have 5 squared plus B squared equals 13 squared. Okay? But now we're going to have to just solve this like a regular equation. We want to simplify the exponents. So we have 25 plus B squared equals 169. And then to get the b squared by itself, we want to subtract 25 from both sides. And that gets us with b squared here, so minus 25. Cancel out, and minus 25 here. And that gets us b squared equals 144. And this is where we do the square root of both sides to get b by itself, and that equals 12. It could potentially equal negative 12, because negative 12 times negative 12 equals 144, but you can't have a negative side length. So that's why it's just positive 12, meaning the side length would be 12 centimeters. Okay, so that's not a whole lot different than finding the hypotenuse, just essentially one extra step. So here's what I'd like you to do is to pause it again. Try doing that on your own. With the situation here, it says, what is the side length A in the triangle at the right? Again, we're looking for one of the legs. So why don't you pause it and try it, and then you can check with me in a sec. Alrighty then. So plugging in for the Pythagorean theorem here, we've got a squared plus 12 squared equals 15 squared. Okay, because 15 has to be the hypotenuse, so that has to be the c. And that is the one that's opposite of the right angle. Simplifying the exponents, we get a squared plus 144 equals 225. And I subtracted 144 from both sides just to get the a squared by itself. And that's equal to 81. And then when you take the square root to solve it, you get a equals 9. Meaning, our final side length is 9. There are no units there, so whatever units it would be. So that's how you use the Pythagorean theorem to find a missing side length. Now the second use we're going to have here is going to deal with determining if something is a right triangle or not using the Pythagorean theorem. So let's just read this through here. It says an if-then statement, we kind of talked about this before, such as if an animal is a horse and it has 4 legs, is called a conditional. So conditional statements are if-then statements. Conditionals have 2 parts. The parts following the if is the hypotenuse. The part following the then is the conclude. All right. So the converse of a conditional switches those 2 around. Sometimes the converse is not true, unfortunately. But in the case of the Pythagorean theorem, we're just switching it around, and now we're saying if a triangle has side lengths of a, b, c, and a squared plus b squared ends up equaling c squared, then the triangle is a right triangle with the hypotenuse of c. So we can plug in for a squared and b squared and c squared if we have three side lengths of a triangle and determine if it's going to be a right triangle or not. So let's look at these. It says determine whether the following side measures form right triangles. So what we're going to do is, so for each one we're going to plug in for A, B, and C. And it has to be, the easiest way again is to go smallest to largest. This is A, this is B, and this is C. Same thing here, A, B, C. The one that really matters is the largest one. So on the one on the left we have 7 squared plus 12 squared equals 15 squared. I'm going to put a question mark over the top of these, because we don't know if they're true yet. If they are, then they form a right triangle. If not, then it's not a right triangle. So for each of these I simplified. 49 plus 144 equals 225, question mark. And 729 plus 1296 equals 2025, question mark. And if we add them up on the one side, we see that this is not equal, so this is not a right triangle. This one, however, is equal, so this one is a right triangle. Okay, so that's how you can use the Pythagorean theorem just to determine if a triangle is a right triangle or not. So I'm going to let you do one example with that. Again, still just using our Pythagorean theorem. But here's the example. And if you want to draw it out, you can. Um, could the lengths 20 millimeters, 47 millimeters, and 52 millimeters be the side lengths of a right triangle? And be able to explain, back up your answer. So I'm going to have you pause it. Why don't you try plugging in for the Pythagorean theorem. Make sure you plug in the correct spots for A, B, and C, and see if it's the right triangle or not. All right, looking at this one, we have to plug in 20 and 47 for the two legs, A and B, and then that means 52 is the C because that is the longest side. If I plug in for A squared plus B squared equals C squared, if you see here, 20 squared plus 44 for 47 squared equals 52 squared. We're trying to figure out if that's true or not. Simplifying, we got 400 plus 2209 equals 2704, and they are not equal, so they are not forming a right triangle because they do not meet the converse of the Pythagorean theorem. All right. So that is the second way of using the Pythagorean theorem, or really the third way, just determining if something is a right triangle or not. So I'm going to leave you with this. A student found the length x in the triangle at below by solving the equation 12 squared plus 13 squared equals x. Describe and correct the error. What did the student do wrong, and how could you fix it? That's the last thing I want you to think about going in, finishing up this video, because we've covered our two learning targets, which were to solve problems using the Pythagorean theorem and to identify right triangles. All right, and that is section 1 of chapter 10. I hope you got something out of this section about the Pythagorean theorem, one of the most popular and commonly used mathematical theorems in the real world. All right, we'll see you next time.